All right, kiddos, I told you I would explain how to do this problem. Exercise 10L, number 5. So let's go through it. It's actually not much more complicated than the problems you've already done. Here we want to find out what we're given, what we are looking for, so on and so forth. So let's do this. Okay, we are dealing with the area of the minor segment. So clearly this shaded area, sorry. Clearly this shaded area is what we're dealing with. All right, we're trying to find the rate at which this area is increasing when theta, the angle, equals 1. It's 1 radian. We are dealing in radians. So let me just change this real quick. Okay, what do we know? Well, we know this is 5, this is 5, the radius is clearly 5. That is not changing. The radius is not changing, it's just the angle that's changing. Okay, so then find the rate at which the area is increasing. Okay, so we need to find dA dt. Okay, so that's what we're looking to find. When angle AOB is theta and is increasing at a rate of 0.2 radians per second. Okay, so that means d theta dt, our angle, is increasing at a rate of 0.2. So d theta dt equals 0.2. Now, there's a lot of different ways of finding out what information you need, but using this information that's given to us and trying to get from here to dA dt, well, if I'm going to use this one derivative that we already have, well then, I'm going to say dA dt equals, oops, sorry, I need to move back here, d theta dt times, well, I want to keep dt in the denominator. I need to get rid of d theta, so times dA d theta, right? Because that is going to cancel this and this. Now, the question is, we already have this one. It's been given to us in numerical form. We need to get dA d theta to be able to calculate dA dt. So how are we going to get dA d theta? Well, we obviously have to take into account the area formula. So I'm just going to put this over here on the right side. Area. So here's where we just have to figure out what we're doing. The area of this whole segment, including the part that we don't need, is going to be theta, whatever our angle is, over 2 pi times pi r squared. Right? The area of just that shaded portion is going to be this whole area minus the triangle in there. And so we can use 1/2 AB sine C to take the area of the triangle there. And you know what, let me just erase this. So we're going to take this area formula and subtract 1/2 AB sine, in this case it's not C, it's sine, whoops, theta. Whoops, there we go. Okay, we know that our radius is 5. So let's finish filling this in. Our area is going to be theta over 2 pi times 25 pi, oopsies, minus 1/2 times A and B are both 5, right? So times 25 times the sine of theta. Okay, so let's go ahead and simplify then. We're going to have here, area is going to be, what is that, 12.5 theta? When we simplify that, minus, again, 12.5 sine of theta. Okay, so what was the whole point of this? Okay, first of all, what did we just calculate? We just calculated the formula to find the area of this shaded segment, the minor segment, as in reference to the angle theta. So we need to find dA d theta. Let's get that. Let's find the derivative. All right, so this is already in terms of A and theta. We're just going to take the derivative of both sides. So dA d theta is going to equal, oh, I'm sorry, this should have been, 12.5 theta. That's not 12.50. It's going to be 12.5 minus 12.5 cosine theta. Using our trig derivatives. Sorry, that is super messy. And now we can use this dA d theta in our original formula. All right, so we're going to say dA dt equals d theta dt, which was given to us, is 0.2, times, well, let me find out what this is when theta equals 1. All right, so let's just put that in our calculator. We have a radian of 1. You know what? Just to be precise, I'm going to write it like this. Minus 12.5 cosine of 1. Because we're trying to find the rate of change of the area when theta is 1. And if you type that into your calculator, you're going to get, what is it, 1.15? Hang on. 0.2 parentheses 12.5 minus 12.5 cosine of 1. 1.15 approximately. And so let's use our units correctly. 1.15 what? Centimeters squared per second, because we're dealing with area. Centimeters squared per second. Ta-da! We're done. All right, so that is one last problem that you're going to do on your homework. Also, problem 2 from exercise 10L is one that we did yesterday, so you don't have to do problems 2 or 5, but please complete exercise 10L before you do your exit ticket for this weekend. Okay, toodaloo!